Ah. Oh. Good morning, everybody. I guess I'm hiding my chat there. Yeah, I see you guys. Hello, hello. Welcome. We're going to have a better streaming day today. Good morning, everybody. Today, we're going to have a better streaming day. We're going to have a good connection. My computer may take a nap once. I'm going to spill water on my glasses. Off to a great start. All right. So connection's looking okay, so we're going to try our best today. On Friday, we had some bad connection issues, so if that continues, then we might end up swapping to something like WebEx for the remainder of class, but we'll see how today goes. So last night was the late deadline. Last night was the late deadline for the strings assignment. I know that many of you got it done, so I hope that that went pretty well. We're going to talk real quick about assignment 5. I have the code grade for that mostly complete. I had to go get some technical support from them. So this afternoon I plan to have assignment 5 up, and I'm going to make it due on Wednesday. I'm going to try to do the late deadline for Thursday. And then tomorrow we're going to talk about submitting your programs using CodeGrade. So I plan to have that by tonight. If you didn't see that announcement yesterday, I would like to have assignment 5 due on Wednesday. Now I just kind of want to remind everybody how we're doing right now, schedule-wise. We're in the last 2 weeks, right? We're in the last 2 weeks of this. If I pull this over here, maybe a little bit hard to see, but we're sitting here on this Monday with templates, right? This is us right now. And so we're in the last 2 weeks. Now I said we were going to have 9 total assignments, and right now assignment 5 is out. So we're talking about assignment 6, 7. Let's see, we have a templates. Yeah, so we have an operator overload assignment, a templates assignment, a recursion assignment, and then a final project, which will cover linked lists, stacks, and queues. So that's 4 more assignments on top of assignment 5. So here's how it's going to go. All right, here's how it's going to go. Assignment 6 might be a little heftier than some of the other ones that we've had. Like I said, in terms of lines of coding, assignment 5 should be around 50 or so, around there. And I would say assignment 6 is going to be maybe 3 times that amount. So I'm going to give you some time for that. But then the templates assignment and the recursion assignment, I'm going to make them little mini ones. So they're going to be small, tiny assignments, but that also means I'm not going to give you a week to do them. All right? So just so you know, assignment 6 is going to be a bigger one. I'll probably talk a little bit about it today. It will be going up today as well, since we're finishing up operator overloading. So once again, assignment 6 will be going up today. And like I said, it's a little bit of a bigger one. I wouldn't say it's hard necessarily, but it will just kind of require a little bit of work. And then once again, assignment 7 and 8 will be little tiny ones. And then assignment 9 is your final project. And the final project, I plan to have it go up by next Monday. So just kind of be on the lookout for those things. Be aware of your time. Make sure you're kind of working on these things and getting them done. So there's that. Tomorrow, like I said, I'll go over CodeGrade submissions. I should be pretty good, actually. I've been kind of messing with it. It's not too bad. I don't like it very much, but it's not too bad. And also, just a quick little bit about that. I do make you do the comprehension questions on every assignment. Now, CodeGrade doesn't care about those. CodeGrade's not going to do that. So what I'm going to do is I'm going to make the comprehension part of your assignment like a quiz. The quiz will have unlimited attempts up until the deadline. And so instead of doing a text file, just fill in your questions on the Web Campus quiz. So I'll get that going too. I'll go over that tomorrow. I'll remind you guys. So now that that's all said and done, we're going to go ahead and get started today. I'm going to review what we talked about for operator overloading last time. And let me know if you guys have any questions, okay? I know I can see some okays in there and some all right. So let me know if you have any questions. And if anything seems like ridiculous, like I'm having you do something ridiculous, then please let me know so I can adjust myself. I don't think, if I get CodeGrade up tonight, even if you have assignment 5 done, you're still going to be able to have a little bit of time to submit it at some point. So I know that's kind of been a pain, but just let me know if you think I'm being ridiculous. I'm trying not to be. I'm trying to watch our timeline here. I want to get you guys through this class and on to the rest of your summer. So, last time we kind of wrapped up our operator overload notes, right? And then I was trying to do, you can see here we've got this matrix code, right? And I was trying to walk you guys through some operator overloads, and I threw some curveballs at you. So I'm going to review some of those curveballs, and then I'm going to do just a few more operators for this class, and then we're going to move on to our next subject. Our next subject is templates, which is not too bad. There's not very many curveballs in that one, all right? So let's get through this operator overloading today, and then we'll get started with our templates. So I'm just going to go over the notes like I always do, and I'm going to leave off where, or I'm going to start where we kind of started on Friday. So let's see what kind of how far we got. So I believe we already talked about our friend functions. And I think on Thursday, we kind of got through all of this stuff up until this point, right? We talked about what operators must be a part of the class, and we talked about what operators must be global, and how every other operator can be a choice, right? You can say, hi, I want this operator to be, I would like this operator to be a part of my class, or I would like this operator to be a global operator. You know, every other operator you can do that for except for these 5, right? And then, of course, except for these 5 up here that you just can't overload at all. So you can kind of just take these out of the picture. And when I'm asking you these questions, even on the assignment or on a test, I'll say which operators belong to the class, it's these 3, and which operators belong to the global scope, right, or the outer scope, it's these 2 operators. These ones are pretty easy to remember, and though there's some confusion on this when we talk about why that is. Now, when it comes to these operators, recall that there's always an object on the left-hand side. That's just a fact, and so that's kind of concrete, and you can rely on that. Now, this down here gets a little bit confusing because, in some sense, an if stream is a class. And so I always like to explain it this way, in that your object will always be on the right-hand side. And that's pretty true. But for some other reason, C++ just will not allow you to overload these as members of the class. It just doesn't let you. And I tried to find the reason for that last time, and it wouldn't let me. So when I ask you this on the test, we're going to answer it this way, meaning that at least whenever we overload it for our classes, our object is on the right-hand side of these operators. Never once in this class do we make it some sort of stream class, like an in file or whatever. I think C++ for the most part does that for us. So this is the reason for that. Whenever I ask this question, there's always an object on the right-hand side. And always remember this, that these 2 operators, they have a very specific syntax. Pretty much every single time you overload these, this is how it's going to look, all right? Now, I did these already as an example. I think I did both. Let's go take a look. Maybe I just did one. All right. So I just did one. I'll do the other one today as well. I just did one. But they always follow this kind of syntax. So if you want to kind of remember this, if we're going to do the insertion operator is the one that goes to the cout, right? As if we're inserting characters to the cout. That's kind of how to think about it. It's always going to look like this. OStream. Right, that's the type. That's what the stream is. It's an out stream, right? That's the O part. So that's O for out stream. And we're actually going to return it by reference, all right? So this and% goes here, and that's because we're returning not a copy of the stream, but we're actually returning the stream. And then you have your operator. And let me make sure I got that right. I usually do. Yeah, that's fine. I guess you can put the and here. Doesn't really matter. It'll compile either way. And then what does that operator look like? Well, it looks like that, right? So we're going to put that right there. And then this is very important. We have to pass the O stream by value, or by reference. We always have to pass this by reference. You see, because we're returning by reference, we have to pass it by reference. If we did not do that, we would end up returning a reference to this local variable here. And so when this operator goes out of scope, your program will die. All right, because it's going to return a reference to deallocated memory. So you have to pass it by reference always. And then because this is the insertion operator, we can pass whatever our object is, like our class object here. Okay, you would like me to repeat that once more. I think you're talking about what I said here. Let me kind of open up here in the code. So, So here's this bit, right? So do you see specifically here we're returning this outstream by reference, right? So we're actually going to return the address of whatever this is. So notice down here I say return out. It means we're returning this object. And whatever it is, when we return out, we're not returning a copy of it. But actually we are returning the reference to this variable. And so this variable has to either be global, it cannot be declared within the body of this operator. And it is kind of declared within the body, right? So right now, as you can see, this is a pass by value. This is a pass by value parameter, which means, let's see if you guys remember this. We kind of spent a lot of time on this. Whenever we pass something by value, what constructor gets called? Of the OStream class here, what constructor is called if we pass something by value? Whoop, go away. We spent a lot of time on this last class, right? Yeah, Cherry's right. The copy constructor is called, right? So this is actually a copy. If the ampersand is not here, this is a copy. This is a, if the ampersand is not here, we have a copy of the object. And so the scope of this object is from this bracket to the return, right? That's the scope of this object. And so if we return a reference to, this is a local parameter, meaning that the scope of it is only this function here, right? That's all of its scope. If we return a reference to this local variable, when we return, this local variable gets deallocated, right? The destructor is called. And so all that memory gets deallocated, and now what's returned is a reference to a variable that no longer exists. Because the variable was local, its destructor was called, and this reference will no longer be valid. Now, the explanation that I just kind of gave you, it's not really a test question. I'm not sure, that is kind of a hard concept, but I would say that's more of a CS 135 thing, though I probably know you guys didn't really cover that. So I won't ask you anything like that on the test. I would rather just you memorize that it's a, just memorize that this is a return by reference and this is a pass by reference. Always include that ampersand there. All right. So this is the syntax for that class. All right. And then somewhere in here, it always looks like this. I swear it always looks like this. You can memorize it. You're going to have some code here. And then you're going to return, let's give it a name. I usually call it out or the left-hand side. So we'll return out. And that's your insertion operator. The extraction operator is a little different. So the extraction operator is actually an I stream. It's an I stream for in, right? Not out, but this one's in. This is the one that gets called from cin, as if we are extracting stuff from the stream. And so in here, we are going to pass the I stream by reference. We're also going to return it by reference, and we're also going to return it down here. So in the sense, these are almost identical except for the iStream part. Now there's one more little bit here. Do you think that this object here should be a pass by value or a pass by reference? Now remember this. This operator gets called when you say something like int x, and then you see in something to that x, right? So in a way, you're calling this operator here like this, and you're passing in cin as a parameter, and you're passing in x, right? So do you want this x to be a copy or by reference? Cherry is correct, right? It's by, you want it to be by reference. And the reason for that is because you're going to be changing stuff within the object, right? Whatever the user enters in here, you want it to be recorded in there. So you definitely want to make that by reference. All right? So just remember this. This is the syntax for those two functions or those two operators almost always. Like 100% of the time. When I say on the test, can you overload this operator? You go, which one is it? The extraction? I'm going to do this reference thing. And oh, this is the extraction operator. Let's make our object go in by reference. Oh, this is the insertion operator. We can just make this a copy. It's fine. All right, so you have that. And today I'll do this operator. Last class we did the other operator, right? Notice that we did pass it. We did pass it by value. It's a copy. And we're just sending it out. We're just sending it out to that O stream. So then I gave you some syntax, right? I spent a little bit too much time in here. So let's kind of talk about what's going on. If it's a member of the class, you have the type. And then you have this keyword operator. And then whatever the operator symbol is, right? Is this a plus? Is this a plus plus? Is this a less than and equals equals? Whatever that stuff is, right? So there's a symbol there. So Sero, it is not insertion. Now, it's confusing. You have to think about it almost backwards. And I used to believe the way that you did too, right? And that I would imagine that this is inserting to this object, so I would want to call it insertion. But you have to think about it. You have to think about it in terms of the stream. So stop thinking about the object and think about the stream. What are we doing to the stream? In this case, we are inserting something to see out. In this case, we are extracting something from cin. Does that make sense? So just think about the stream, not the object. Just think about the stream. What are we doing to the stream? So you got your type, the keyword operator, whatever the symbol is, and then whatever parameters you're going to pass into it, right? So I gave you an example of this, right? This is the int operator plus. Now, if you want to make it globally, right, it's the exact same thing. It's the exact same thing, but you do have to consider what objects are going in here. So if you're not making it a member of the class, but you are going to pass, if you are going to pass an object, you might have to consider making it a friend operator so that this function has access to the private members of that type, of that object. So I'll give you plenty of those examples today. I kind of already did. And then the last thing we talked about is the pre-operation, the pre-op and the post-ops, right? So you got the minus minus and the plus plus. Now this one bugs the heck out of me, right? Because you are allowed to make the pre-operator. You are allowed, this is the pre-operator. You're allowed to make that a member of the class, but notice the object isn't on the left-hand side of it. So that's a little bit annoying. And I just want you to cover your eyes, okay? The pre-operator is allowed to be part of the class as if you're calling it like this. Plus plus. Now the pre-operator, well, let's see. You can't see it. So does anyone remember what the difference between the post op and the pre-op is when in terms of just the prototype, the function or the operator header. What is the difference between the operator header in the post-op and the pre-op? It's kind of a fun one to remember because, I mean, what I mean is that, well, first, Synchro, what I'll say is if we're going to overload these operators, we can make them do whatever we want. So that's the thing. Yeah, there you go. That's what I was looking more for. So remember this. On the test, I will never ask you what the int post-op pre-ops do. All right? That's kind of a CS135 thing in my opinion. So I'll never ask you what they do. When it comes to operator overloading, we can make them do whatever we want. All right? We can make them do whatever we want. So whether or not it returns the object before the change or after the change, that's up to us. That's totally up to us. So Synchro got it there. I was asking what's the difference between the post-op and the pre-op. Well, this is the pre-op in that it doesn't take, if it's a member of the class, let's kind of look at it down here. The pre-ops, if they are members of the class, they're going to take 0 parameters. But if they're globally overloaded, they'll take 1 parameter. And what is that parameter? It's the object. Now, when we talk about the post-op, this is what Synchro responded with. The post-op takes 1 dummy int variable. It's like an function overload almost. So the way the compiler tells the difference between the post and the pre-op is that it passes in a dummy integer. And so if it's a member of the class, it takes in 1 param, right? And that's going to be the dummy int. But if they're globally overloaded, if the post-op is globally overloaded, it takes 2 params. One is the object, one is the dummy. All right? And I gave you examples of that, right? So you notice this one is taking this int here. That's a dummy int. So that dummy int means that this is a post-op. Notice here that this one is also taking a dummy integer, an integer parameter. So that is a post-op. But in the pre-op, notice that there's no int in here. Notice that there's no int in here. So these are the pre-ops. All right. So that's pretty much all we did. And then I talked about this fun trick in the copy constructor. This kind of threw us all for a loop. I'm going to be doing more of this today. So hopefully you'll kind of understand what this does. But whenever you call the copy constructor, or whenever you're defining the copy constructor for your classes, you can not write any code almost. If you would like to skip a bunch of code, you can just write this. You can just write that little line right there. Now, can anyone tell me what that does? I know some of you know. What does this highlighted portion do? Specifically, what does this well, there's a comment there, but I already asked the question, so hopefully you can read. What does that portion do? Getting ahead of myself. Thank you, Cherry. Yes, it calls the assignment operator. It calls the assignment operator. So the copy constructor and the assignment operator always almost perform the exact same way. Except there's one major difference. In the copy constructor, it's a brand new object, meaning that these should be initialized. These parameters or these member variables, they need to be initialized before you do anything. But in the assignment operator, the object is likely already alive, so you need to first deallocate whatever memory was in there. But then the rest of this code is identical. This code is in the copy constructor. This code is also in the assignment operator. So as long, and this is in the copy constructor, as long as you initialize these values always. If you don't initialize them, you'll get some undefined behavior. But as long as you initialize them always, you can just type this little bit here. And what this says is it takes this, whatever this is, right? This is a pointer to the object that we're creating. And so if we dereference it, the type of this thing is now a matrix type. And so I'm saying set this equal to the copy. So it forwards us down to the assignment operator, and then it does all of this code here. All right? So that's a fun little trick we talked about. Now, if you remember, I did the matrix plus plus. This is how we finished out, right? In which I went through every cell in the matrix and I increment it by 1. I have a question here. So just make sure we initialize, then deallocate, and we can use the trick. Well, in the copy constructor only. So the thing with the assignment operator is that you will always deallocate, all right? You will always do this step. You will always do this step, no matter what. So as long as your assignment operator is correct, and if it is correct, you will have deallocated memory here already. So the thing to remember about the copy constructor is that you can always use this trick as long as you initialize these values. So I would say just the first part of it is make sure you initialize the values and then you can use the trick. Because the assignment operator is already supposed to deallocate the memory. It's a requirement of this. If you don't do this part, you're going to get memory leaks. So remember in the pre-increment operator here, I just went through everything and I incremented it by 1. Now we're making this operator act as if it's the regular int pre++. Meaning we're going to increment everything in the matrix and then we're going to return that matrix with everything incremented, right? Just as if it was an integer. And so this little bit may have confused some people. So just remember that, you know, if we call plus plus down here, let me see it. If I call plus plus on this matrix, I shouldn't call it this matrix, but let's call this this mat. If I call plus plus on this mat, then this is a pointer to this mat, right? So I called, I'm in the wrong operator. I'm sorry, folks. Where am I? Here I am. So we called the pre-op on it. So remember that this is a pointer to this mat, that object. So within this object, if this helps you at all, remember you don't have to do this if you don't want to. But this matrix here belongs to the object, right? So we're going to increment everything. And then I'm going to return a copy of this mat. So I take the pointer and I dereference it. And then it'll work. So I'm going to do that a few more times today. So let me know if you need some help with that. So the next thing that we're going to do today is, so notice here I did the pre-increment plus plus. I'm going to do the post plus plus, but I'm going to make it a global operator, all right? So if it's a global operator and I'm going to do the post, if it's a global operator and I'm going to do the post, can you give me an idea of what kind of parameters I'm going to need? Call it post plus plus. Or what parameters, I'm sorry, what parameters am I going to need for this operator? So we're going to make it return a matrix and it will take a dummy and an int. That is completely correct. So I'm going to make an operator here. and I want it to take a matrix object. Now, do you think if this plus plus operator is going to be making changes to the object, do you think that this should be a pass by value or a pass by reference? And then it's going to take a dummy int here. Do you think that this will be a pass by value or a pass by reference on that matrix? Now, I'll give you a kind of a little bit of a hint here in that this will increment everything. It'll increment everything in the matrix. This will increment everything in the matrix, and then it will return the matrix before it was incremented. All right, so this is working exactly the same way as this would. So if I said int x is equal to 1 and I see out x plus plus, we're going to see 1 here, right? We're going to see a 1 there. So it's doing the exact same thing as it does with an int. That's how we're making it work. So in this case, yes, it will be, you guys are correct, a pass by reference, because we're going to be incrementing everything in this matrix. Now, if I want to give this operator access to the private members of this matrix, what else do I need to do? Yeah, I need to make it a friend. I need to make it a friend. So I'll just grab it here. Copy it. Notice I'm just copying the header there, the prototype. I'm bringing it up here. I'll go find where my friends are. I kind of like to put them all together. I say, hey, you're a friend of this class, all right? You're a friend of this class. So now that it's in there, we're good to go. So we'll come down here. And we're going to do everything that we did in this operator. All right? I'm going to do this, just this little bit here, right? But this is a so I would like a yes or a no, kind of. Because this is a hard part about classes. So please tell me yes or no. Does it make sense why I have to do mat.matrix here, but when I'm up here in the class, I don't have to do mat.matrix? Can I get a yes or a no on that? When this operator is a part of the class, I can just type matrix out, but if I'm making a global, I have to pass in the object and do a mat.matrix. So I make sure, because some of us are still not there, right? So I just want to make sure. Yes, exactly. I like that. If you guys have trouble with that, write down what attacker said there. All right, write down what attacker said. Up here, this is implied, right? So there is an object here. There is an object here, but this part is implied. Very smart. Very good. Very good. So I want to return the mat, but before it was incremented, right? So do you guys have any ideas on what I should do here? What's a good way? Down here, I need to return a matrix. But it can't be this one because I've just incremented everything. So what do you think, or what should I have done? Do you guys have any ideas? And I gave a little bit of a hint up here. Notice I put an enter here, right? I put an enter here. Oh, let's see. Where are we here? No, I don't want to call that operator. That will print it out. I just want to return. So in a way, our matrix was 0, 0, let's say 0, 0. Coda's on the right path there. And then I call a post op here. And so now the matrix goes to 1, 1, 1, 1. But I want to return a matrix that was 0, 0, 0, 0. And so what I'm going to do is up here, I'm just going to say matrix, return matrix. And I'm going to make a copy of the mat. And then in here, I'll increment everything in the mat, but then I'll return the return matrix. Does that make sense? Returns a version of matrix before the increments, right? You guys can follow along with that, right? We're going to copy it up here. So this matrix, when we make a copy of it, it will be 0, 0, 0, 0. And then in here, I'm going to increment everything in this. I'm going to increment everything in this referenced matrix. Notice I'm not doing this. This might make some sense. Notice I'm not doing return matrix I j plus equals 1. Notice I'm not doing that part, right? So everything in this matrix will be incremented, but everything in the return matrix, in which we copied it, right? We copied it before we did anything, will not be incremented. So we're going to return an old version, right? We're going to return an old version of that. So I'll do some couts in main. I'll do some couts in main so you can see how it works. All right. And let's get one more example in here. But before we do that, let's go ahead and just run the code. I think that'll be helpful. So I just want to make sure. Pretend we have a 1 by 1 matrix. So this matrix holds ints, right? This matrix, it holds ints. So if we have a 1 by 1 matrix, basically what is that? What am I saying? What do we have? What am I saying when I say that? I'm saying that we have an int, right? I'm just saying a 1 by 1 is an int. I have a 1 by 1. That means I have just an int. Right, yeah, Coda, you got it. Probably that we're on a little bit of a delay. So I just want to make sure we follow. Let's pretend we have a 1 by 1 matrix that's 2. What is the output of this code? Based on how we worked it, right? What's the output of this code? What will we see here? What will we see here? What will we see here? And what will we see here? Wait, hold on. Well, maybe you'll get it right, but I wanted to change this, so I'm sorry if you're already typing. I know I'm asking a silly question. So, Synchro, I kind of changed this up on you last minute, so I'll give it to you. But this is our pre-op, right? And what did we do in the pre-op? We incremented everything, and then we returned it. So this will be 3. And now it's 3. And then it's 3, and then it's 4. I'm really sorry about the confusion there. So this plus plus increments everything in this mat, and then it returns it. So we'll get the 3, and then what is it now? It's still 3. And then the post, it increments everything in this mat, but then it returns a version of this mat that it's not incremented yet. So we'll see 3, and then it will be 4. So that's roughly what we'll see, but notice we're going to do a 4x8 here, all right? So the 4x8, it'll be a little bit different. It'll be a little bit different. So let me get Bobby going here. Wake up, Bobby. Wake up. Thank you. Alrighty then. Now maybe I want to do a little see out here. Why not? We've kind of been doing that, right? I kind of wanted you to review this code, right? With all of the see outs I put in it, you can follow exactly what's going on. So let me just throw that in there. And then I'm going to do my favorite G++ statement, std equals C++11, and then we're just going to do oo.cpp. I'm going to do a nice clear statement here, and I'm going to run it. Now, we're going to skip over everything that we did. And where are we left off? So we're left off with this 1, 1, 1, 1, 1 matrix, all right? That's where we are. And so if we're at 1, 1, 1, 1, we should see hopefully 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and then 3, 3, 3, 3. But let's see here. Unless I made a mistake. Oh, no, I messed up. I'm sorry, folks. I'm sorry. So we're starting at 0, 0, 0, 0. We're starting kind of at that matrix. So in this case, we'll see the 1, and then the 2, and then the 2, 2, 1, 1, 1, 2. I think that's what we'll see, right? So where's our pre-op? Here's our pre-op, right? We called the pre-op, and we get our 1s, because we started out at the 0s. So our pre-op gives us our 1s, and then that matrix is equal to 1s. And then I called the post, right? And we return a copy of that matrix that are 1s. And then we check it out again, and we've got our 2s. All right? Confusing myself there a little bit, but it's there, right? We got that right. 1, 1, 1, 2. If we're starting at 0s. All right? So hopefully that's all good. I'm going to do one more operator here, unless there's another one you'd like to see. Just let me know, if we need to spend some more time on stuff. So, well, maybe I'll do 2 more. I'll do 2 more. The first one I'll do is I will do this one, the other one. So, what's the other one called? Let's see if we remember. If I'm going to do whatever this one is here, what do we call this one? What do we call this one? Think about what it's doing to the stream here. What does this part do to the stream? The extraction, that's right. This is our extraction. What is it doing to the stream? It's going to pull something out of the stream. It's going to extract from this stream. I know, the in, right? The in. It's confusing. So just try to remember that. We're pulling something out or we're putting something in. Should have called that insertion, right? So the way I want to do this one is, let's say we have a 4x4, too big for my example. I want a 2x2, and so let's say our 2x2 looks like a 0, a 0, a 0, a 0. And then let's pretend I read in this string of numbers, 1, 2, 2, 7. I want it to look like 1, 2, 2, 7. All right? So that's how I'm going to make this operator work. So for every cell we have, I'm going to expect some input. I'm going to expect some input. It's going to go 1, 2, 2, 7, and it will put them in row major order, right? It's going to go, this is the first row, this is our second row. So pretty simply put, we'll do it just like we've done with everything in this matrix. For in I is equal to 0, for I is less than the mat's height. Did I call it mat? I called it M. For the mat's height in the I++, and then we'll do another for loop for int j is equal to 0. J is less than our mat's width, j++, and then I will into the mat dot matrix at I and j. And then tell me, what does this operator return? What am I returning from this operator? This is always the case, all right? At least for this class. What am I returning from this operator? In terms of this class. And what Mr. Petrowski said earlier. What am I going to return from this function, from this operator? Nope, that's not quite. So you remember I kind of talked about this. I could see in something like x, and then to y, and then to z. And so this is a binary operator. So this is the first option. Yeah, there you go, Synchro. That's right. And then this is the second operation. And then this is the third operation, right? So what does this return? This bit here returns Cin. So if that bit returns Cin, then we're now stuck with that. And if this bit returns Cin, then we're now stuck with that. And then if this bit returns Cin, then we finally have that. Sorry. Yeah, you did get it, but I'm just talking about it, right? We're going to return in. And that's it. Very simple function here, all right? Very simple. So we're going to test it out. This is a fast-paced class, that is for sure. Let's see. Yeah, that's fine. So notice that we're going to overwrite everything in this matrix, all right? We're going to overwrite everything in this matrix. Now, we could do some fancier stuff in here. We could prompt for a new width and a new height. I'm not going to do that, all right? I'm not going to do that. And in your assignment, I give this one to you. This function here specifically, this operator here specifically, I give it to you for the next assignment because it is just sometimes a little too much for us to handle. And the problem with this is, imagine you're reading from a stream into a string. How does the string store its characters? It stores it in a character array. And so the question is, how do you know when to stop? And so I would never put you through the hell of trying to figure that out. That's only, that'll be up to you when you're a graduate student like myself, or when you're in CS 302, just trying to go above and beyond. But in this class, I give this one to you. All right? So just remember, I'm not prompting for a new width and a height. I could do that, and then I could deallocate and reallocate and see in all this stuff. I'm not going to do it. We're just going to pretend like we're going to overwrite whatever that matrix already was. So I'll show it to you, and we'll kind of go a little crazy here. But at this moment, I will see in this mat, and then I will see out this mat. Let me get a little print statement in here for us. This is our extraction operator. We're having a good streaming day today. connection seems fine. So let's G++ that, and let's run it. So notice here we called, it went through all of this stuff, right? It went through all of this. And now we've called the extraction operator. I'll try not to jinx it. We called this extraction operator, and now it's going to wait for me to input all of these. So what is that? It's going to be a 4 by 8. That's 32. So let's enter 32 numbers. I'm not counting, so we'll see when it finishes. I just want to be careful. There you go. Does it make sense how that worked? What it did? It's pretty ridiculous, isn't it? But that's what it did. And then there was some other stuff called down here, right? Here we call the insertion operator at this point, right? That's fine. So that's what our extraction operator did. That's what our extraction operator did. So now I'm going to do one more for you guys. Yeah, I'm going to do one more for you guys. I'm thinking about doing matrix multiplication, but I kind of don't want to take the time to do that because that'd be row every element in the row times every element in the column summed. We could do it someday, but I kind of want to move on to templates. I'm not going to make you do matrix multiplication for your assignment. I'm sure you guys are smart enough you could figure it out on your own. So if you're feeling bored today, why don't you go ahead and do this. Here, I'll give you a for fun. For fun, if you're excited today. If you're feeling above and beyond, go ahead and do this one. Matrix operator times takes in a matrix on the right-hand side. So if you're feeling fun today, go ahead and do that one on your own. Notice that this is a member of the class, so there's two things implied here, right? There's a this times the matrix, right? That's what it looks like. It's like saying you're taking this and you're multiplying it by the matrix, the right-hand side. The one that I will do for you is, how about we just do some plussing, some addition, some fun addition here. So we're going to take the matrix on the right-hand side, and that's what we'll do today. So let's say, just so I can show you how this one works, let's say we do 1, 1, 1, 1, and say we're adding it to 2, 2, 3, 1. All right, so Cherry, this is very important. You ask a great question. There are two parameters for multiplying, but is this a class member or is this a global operator? Is this a class member or is it a global operator? It's a class member. So the right-hand side is here, and then we're using this as the left-hand side. Now, here, I'll give you just a quick little tidbit here. If I wanted this to be a global, I would make it do this. If I wanted it to be global, I would make it a friend, and then I would pass in the left-hand side. Does that make sense? I said on your assignment that you're allowed to make them global. I wouldn't do it because I want to see your kind of ability with this, and then that way you don't have to do much conversion. But on your assignment, I did say if you wanted to convert some of the operators to global, you can do it. But if you do that, you're going to have to remember to add this little bit in there. So just remember that. So it's like we're taking the this plus the right-hand side. And so if we do that, we're going to end up with, say, like 3, 3, 4, 2. Does that make sense? 1 plus 3 is 4. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 2 is 3. All right? That's kind of what we're doing. So this one's really easy. I'm going to speed run it. All right? So notice that we're returning a matrix. Notice that nothing in here is passed by reference. We're not going to make a change to this object, right? Whenever you do something like int x equals 0 and y equals 4, and then you say int z is equal to x plus y, remember that nothing, the x or the y are not changed. X will stay 0 and y will stay 4. So we're actually not going to change anything in our object or in our parameters, but we will be returning something that's new. All right, so if I'm going to be returning something that's new, I would love to have maybe a matrix, return matrix. And how big is it going to be? Well, it's probably going to be the same as the width or the height from this object, or the width or the height from the right-hand side object. So let me see how I called it up here. It looks like we pass in the height as the first and the width as the second. So let me go ahead and do that. We're going to pass in the height, which happens to be the height, and we're going to pass in the width, which happens to be the width, right? And this is implied here, right? This is implied for that. And we're going to do a fun little for loop. I'm just going to go find my favorite for loop because I do it 17 times in this class here. All right, I don't know why it's doing this thing. Probably because of my comments. And then what am I going to do in here? Well, this one, it's going to be a little long, but I'll say the return matrix dot matrix located at I and located at J. I'm going to go vertical here is equal to this matrix, right? So matrix located at I, located at J, plus the right-hand side matrix located at I, located at J. All right. I went a little bit vertical there. I know some of you like that. That makes sense, right? That's our code. And then at the very end of it, we're going to return our return matrix. So I think I'm going to make a few things. Let me see here. So that should all be good. I want to make this maybe just a 2x2. And I want to make this maybe a 2x2. It looks like I overwrite them anyway. And then I'll plus plus on this mat. And then let's say I see into my mat. And then I will see out this mat. And then I will see out this mat plus my mat. So tell me if you understand this here. In this expression, which object is the right-hand side parameter and which object is this object? So which one of these is this and which one of these is the parameter? The right-hand side is my mat, and this is this mat. That's correct. That's 100% accurate. It's very good. So let's just run our code, and then we'll be moving on for the day. So if you've got some operator overloading questions immediately that you think that I need to clear up, please let me know so that I can assist you before we move on. Otherwise, you can just come to office hours or send me messages. You guys know I do respond to you. Okay, so we'll run it. All right. So let's just kind of get our bearings. I think one of these guys is going to be, this mat will be 2222. And now I'm going to enter my mat. So let's make that just, I don't know, 1, a 2, a 3, and a 4. And so if we take, what did I do? Yeah, so if I take, did I not print it right? I kind of want to print it. Whoops. That was not proper English. I'm really sorry, guys. I really wanted to print it out. I wanted to print it out. And this is a question that I ask you on assignment 6, so give me your best rendition. Why do you think we do operator overloading? In case you couldn't tell, all of this stuff could be represented as functions. We could just make everything functions. So some of you might be like, why are we doing this? This is stupid. I could just make a function. But why do you think? And I asked this question for assignment 6, so maybe you want to take a little bit of notes. But why do you think operator overloading is cool? We got one answer in there. I'll look at them after I run my code. 1, 2, 3, 4. All right, so we're going to take 1, 2, 3, 4 plus 2, 2, 2, 2, and we're going to end up with 3, 4, 5, and 6. And I'm going to run valgrind real quick because I just want to make sure that everything works and that I'm handing out decent code. Yeah, okay, we're good. So I'm seeing ease of code. I see reuse. Yeah, so I think you guys are really summarizing two things. So there's kind of two parts to it. So maybe write this down. I kind of want you guys to think about it. This is more a CS 326 question. So as long as you give me some answer along this line on the homework, I'm okay with it. But maybe you do want to take some notes. The first thing is that just like functions, we're kind of abstracting, we're taking all of this code and we're cramming it into this little plus plus, right? So that the term for that is abstraction, but really we're simplifying like a whole block of code into this small little plus plus. So that's the writability aspect. I'll kind of just put them down here. I don't mind. So the writability. I don't know if that's a real word, so I'll put it this way. But the writability of the code, right? In that instead of doing this every single time we want to do an extraction, we're just going to cram it in that little operator, and then whenever we want to extract, we just call it like this, right? So that's the writability. In addition to that, we've got the readability of our code. The writability and the readability. And that, for example, people understand, I mean, at least mathematicians understand what my mat times this mat means. They understand that this is matrix multiplication. They know that. And so what would you rather do as a mathematician? Would you rather read my mat times this mat, or would you rather read for loop, maybe another for loop, and maybe another for loop, times plus, times plus, times plus? As a mathematician, is it easier to read this, or is it easier to read for loops with a bunch of operations? And it's obvious that the answer is, as a mathematician, you want to see this, right? So operator overloading makes reading the code much easier, right? So that's kind of a question on your assignment. I kind of just gave that answer to you, right? So we have the writability and the readability of the code, and this is why we overload operators. Right? Yeah. I mean, yeah, exactly. Magum is totally right. You would have all these values, and yeah, it'd be a mess. So you understand. You're on the right page, right? So that's kind of our conclusion of operator overloading. So these notes will go up on Web Campus. This final little bit of code will go up on Web Campus. You'll definitely want to reference maybe the OStream operator. You'll probably want to reference this plus, the plus plus as well. Now you're dealing with strings, right? So it's not a one-to-one. But there's going to be some stuff in here that'll help you. So with that being said, I'm just going to briefly introduce the assignment, and maybe I'll talk about it more tomorrow, because I do want to start talking about templates today, because it's on the schedule. Let me see here. So Sync asks, did I miss a video last week? There was one that didn't get recorded by accident, and I did a re-recording. So if you come here, you'll see that we talked about virtuals. What was our week last week? Looked like probably, it was midterm last week, right? So you took a test, and then I talked about virtuals. And then notice here, this video is the re-recording. This should be on the other side. So these two videos should be swapped. All right, so it should go intro to virtuals, and then you come here to the re-recording of that class. And so that's for the people who weren't there. And then you go to a multi-dimensional array plus operators, and then operators. So I did temporarily miss a video, but I got it up there. I did get it up there. All right, so let me just briefly introduce the assignment. I'm still going to clean this up a little bit. As always, my PDFs are long. I know a lot of you probably hate that, but I'm just trying to make it so, you know, when you read it, you can follow it and just kind of go step by step, as almost if it's an instructional thing. Some of you might, you know, I'm sure some of you are genius enough to know what I mean, but I know a lot of people are always even still confused by what I say. So I'm just trying to prevent as little confusion as possible. So we have the same image here, and that's to indicate that you're going to be using the same code from assignment 4. So let's see here. So look at this. I say, so the ones who are here in class right now, this doesn't apply to you. But I do have a portion of the class that watches the YouTube videos later, which is fine. And thank you for that, Cherry. I know I've had complaints before that the PDFs are long. And, you know, I've tried to amend that, but when it comes down to brass tacks, I guess that's a term, when it comes down to brass tacks, I want to give you as much information as I can. You can read this in 20 minutes, right? We're in college. It's not like it's going to take you a whole day to read this book. It's just kind of an instructional... Thank you, guys. You make me feel better. So once again, as I was saying, there's some people who don't come to class always, and that's fine. I'm not throwing any shade. I just want to make sure that they check, say, tomorrow's YouTube video, because if some of you guys come to me and say, hey, what's going on with this operator? I might even give you some code for that, all right? So just like the strings assignment, if you get started on this, in the next few days, I may give you some code for the operators that are confusing you. Now, the reason I'm doing this is because there's 15 operators I'm going to make you overload. Most of them are very small. Thank you. You're making me smile. There's 15 operators I'm going to make you do. Most of them are small, tiny ones, all right? So, but it's still 15 operators. So I would be happy to give you 2 or 3 of them. So, you know, get started on that assignment. And if one of them is like, ugh, what is that? I may help you with that, all right? You know, since we're coming up on the end, I'm going to cram some assignments in. We're going to get through this class together. That's what I'm saying. Now listen to this part. If you successfully completed functions in assignment 4, you will be able to heavily rely on them in this assignment. By using these functions, you will not need to use dynamic memory at all right? So if you didn't get it figured out in assignment 4, come back to me and let's work on your find substring function. I gave you the concatenate function, so if you tried it on your own and it's not working, you better use the one I gave you for this assignment, because concatenate is probably the single-handedly most used function in this assignment. Find substring will be used for one of them. But all I'm saying is you should use these functions, all right? You should use them. Do not try to go from scratch. Use these functions because it'll make your life so much easier. So I'm not giving you a skeleton code because you have your code already. So I'm just going to make you add 16 overloads to your class. Now I've provided one of them for you. As I said, it's the extraction operator. I'm going to give it to you in a text file so you can just copy it into your code. But the remaining 15 operators are on you. Please add the prototypes to your class. What does that mean? That means come up into your class and, where is it? Do this bit, right? Add them here. Or if it's a class member, add it like this. So that means go into your header file and add them here. Now, luckily for you, I gave them to you, right? So if you're not going to change anything, here's the... I kind of provided this screenshot to show you that I was in the header file and I'm in the CS202 class here, right? So you're going to add it there. I gave those ones to you there, and I gave them all to you here, all right? So you can just copy them, basically. But then when you do your definitions, I want you to go into the CPP file and put them there. So now you're going to finally get some practice doing this thing here, right? Doing this thing where if you're not going to put the definition in the class, like I did here so nicely for everybody, you're going to come down here somewhere in your code and you're going to say, hey, matrix, scope resolution, operator, plus, matrix, right-hand side. I don't need that bit. Put the body there, right? So that's all you have to do. So you have to add a bracket operator. That's just like at, all right? Just read this little bit. It's just like at. It's a little different, though. And then the global operators, the insertion and the extraction. The extraction, I gave it to you, right? This one up top, I gave it to you. Just copy paste it in there. But this insertion operator here, you're just gonna put every character from the string into the outstream, and don't put an end line. I repeat, do not put an end line. All right. Remember when you're in your main. Remember when you're in main. And you have something like string G equals, I always use Patty. You say cout G end line, right? So the end line, you're going to be putting it here. So when you do cout your CS202 string, if you put an end line in this operator, I'm going to be unhappy with you. Your output will not match, all right? So I repeat, do not put an end line in there. Just put the characters. All right, so I'm giving you some code there. Give me some more code. Now here's the meat, right? Woo! Look at all these operators. Now I'll briefly explain them. The addition operators are concatenation. The addition operators are concatenation. So you can call the concatenate function and it'll work. All right, so these can be done in like one line of code pretty much. Now notice here I have this array. Now I'm going to ask you right now, here's a good question for everybody. If I didn't want to go looking for that null character in here, is there something already in our CS202 class that I could use to convert this array into a CS202 string? Is there something already in our CS202 class that I can use to already convert this character array into a string, into a CS202 string? What is it? And I want you to realize this, because if I see you in this assignment looking for the null character, I will not deduct you points, but I will be sad that you went through all that work. Ali says toString. I'm going to say no, because toString converts it to an actual string, like the C++ string. But what about a CS202 string? What about a CS202 string? Pushback you could use. You could use pushback in those functions as well, but here's what I'm thinking about. And write this down, all right? Write it down so that you remember the wisdom I bestowed upon you today. Here we go. What is that? What is that thing? What does that do? What does that do? That takes a character array and turns it into a CS202 string. It's a constructor, right? So what can you do here? Listen to this. So you're going to want to write the code. I'm pointing at the screen like you can see me. Let me do a snipping tool. All right, so you're going to write the code for this one here. Now this one could be done in one line. Return, concatenate, string and string. Now this one, the next one, if you convert this to a string, you could do one of two things. You can then call concatenate again, or you can call this one. Does that make sense? You can call this operator. Here's what's going to save you guys a ton of work, especially down in these ones, all right? Especially down in these ones. And listen to me when I say this. You really only have to write the code for these two operators. And then the remaining operators, these ones, are actually just combinations of the first two. So you can always call operators from other operators. So if you convert this to a CS202 string, you can then just call the first plus. All right? So you're going to reuse a lot of code, and that's fine. I want you guys to be as efficient as possible, pretty much. All right? Now, these do something a little bit differently. The pre-op is going to make a copy of the first character and add it to the string. The post is going to make a copy of the last character and add it to the string. What can you use? Concatenate. Concatenate. I would say likely. These two here might be the most difficult part of this assignment, and even then, they're not that bad. All right. So these might be the hardest two, but once again, not that bad. Now the subtractions. Maybe the subtractions will be a little bit hard too. So write those down. Give them a shot. And, you know, if I end up doing these ones in class, maybe I do. In these operators, it's going to find a substring and remove that substring from the actual string. All right. So guess what? Same thing here. Do you see that const char? Just convert it to a string, and then you can reuse this function or this operator. Once again, you really only have to type the code for one of these functions. These two operator overloads are just one. If you can convert this character array to a CS202 string, you only have to code one of them. And then in the other one, you'll just call the first one. Please tell me if I'm confusing. I want you to understand that you can... I'm repeating myself a lot, right? Just code this one right here, the one that I'm scribbling out. Code that one first. And then the next one will be a walk in the park. So it's kind of a 2-in-1 package. But that finds a substring and deletes it. So what functions do I want you to use? I want you to use find substring and delete at. Find substring and delete at. You don't actually have to do any memory stuff in here because you already coded that part. And then finally, the multiplication. This one is say you take beans times 3, you're going to get beans, beans, beans. So it just like takes the string and like keeps concatenating itself with itself. So what function are you going to call in here? Concatenate. You're going to concatenate a string with itself and then do it again and then do it again. However many times that this integer is, right? Beans times 3 is beans, beans, beans. Loaf times 2 is loaf, loaf. Patty times 0 is nothing, right? And then finally, these are operators. They work alphabetically, all right? So less than here, this will return true if the left-hand side string is less than alphabetically the right-hand side string. Now, I only care about the ASCII values, all right? I don't want you to convert it to lowercase. I don't want you to do any of that, all right? You don't have to worry about it. Just compare the characters. Just do an alphabetical comparison using the ASCII values, all right? That's all I care about. And so once you do the less than and the equal, guess what? Once you do those, the not equal is the reverse of equal. The not equal is reverse of equal. The greater than is the reverse of these two, right? Oops. The less than equal is a combination of these two. And the greater than equal is a combination of these two. So this is 6 functions for the price of 2. 6 operators for the price of 2. So I don't want to hear anyone crying to me about how you have to do 15 operator overloads, because really, for this one, you just have to do 2. And once you do these 2, the remainder are a piece of cake. Walk in the park one-liners, all right? So yes, this PDF is 8 pages, but guess what? I'm giving you code. I'm explaining what they do. I'm even giving you hints, all right? So just give it a shot. I'll give you pretty much a week. Today's Monday, so I'll give you like a week to do this one. So, Sikro, so you say this one would be hard. Maybe it won't be, all right? I'm just saying in the sense that you're going to be doing some new things. You're going to be overloading a ton of operators. And I know some of you guys are very confident, but then when it actually comes to doing the assignment, you get a little lost, and in the sense that this assignment is going to have quite a few lines of code. You know what I mean? It's going to be a bit of work. That's what I said. And so, in a sense, you know, I don't want you to be overwhelmed. But if you're lost, right? If you're lost and you're like looking at that PDF, where is it? If you're lost and you're looking at all of these operators, you might kind of want to cry up in a corner and crawl up in a corner somewhere and cry because of how many you have to do. But if you know what's going on, it won't be too bad. But I'm going to give you some time for it. And then remember that the next 2 assignments are going to be tiny little mini ones. Tiny little mini assignments. And then you'll have the final project, and then we're done with assignments. Done with CS202 assignments for the rest of your life, hopefully. All right, so give this a shot. And if any of these operators are scaring you, let me know. Maybe you can convince me to do 2 or 3 of them in class. All right? So that will be going up today. I'm going to prioritize, well, I'll get this thing up real fast, and then I'll do the code grade. And we're kind of out of time, so we all cry, you know. So I don't have time to start templates, and that's fine, so I won't do that. But with these 4 minutes, I'm going to tell you a little bit about how I code, because I know you guys are new to it, and I just kind of want to let you know some things that have helped me in my experience, because I have been in your shoes before. And I have emailed my teachers and, you know, the night before or something. I've done all that stuff. So in my experience coding, I'm just going to tell you a little bit about me. I find, first off, if I just try to get started on something early, say, for example, I open up this assignment and I'm looking at this plus thing. And I'm like, what is this? And if I try for 5 to 10 minutes to understand it and I can't do it, I give up. And I stop for the day and I go to bed. You know, at some point I'll go to bed. And, you know, your mind, when you sleep, it does things. And I have woken up before knowing how to do or get started on functions that I didn't understand. So, what I'm saying is the earlier you get started, even if you don't, even if you don't really do that much work, if you just read it and kind of put it in your mind, while you're sleeping, your brain will do stuff with it. And one morning you might wake up and you'll go, oh, I know what to do. So the moral of that story is get started early. I mean, you don't have to put in 3 hours of work on day one, but at least read it, At least try to put it together in your head. And that always helps. Now, number 2 is try to make pictures. I know I've been sending you guys tons of pictures sometimes on Discord. That find substring function is kind of involved. You know what I mean? That find substring function is kind of involved. And if you just try to, chop it down with an axe, chances are it's not going to work the first time. So try to make pictures. All right. So in this case, this is the delete at function. I sent this to some people. Some of you had a little bit of trouble with this assignment. If you make this picture, notice the main difference here is that the 8 and the 7, and you kind of figure out that you're just going to be shifting things over, right? You're just going to be shifting things over. So you might say I at this location is equal to I plus 1. So if you make pictures, try to visualize it. That'll help you. Yeah. Thank you for all the compliments. And then what's the last thing I'd say? You guys should use COUTs more. Try printing your stuff. If you have a problem and you don't know what's going on, just print it all out. That's like debugging 101. Print it all out and just try to follow it. See where it goes wonky. If you print out a whole bunch of stuff, chances are you might be able to find what's going on. So if you're one of these people who doesn't know how your function is working, and I'm not responding to you, start printing stuff out and see what happens. I know some of you already do that. So those are my 3 things of wisdom. Get started early so you can sleep on it. Make pictures and use COUT as much as you can. I hope I bestowed wisdom upon you guys. And that's our class for today. Tomorrow, unless you start me off on the assignment, I'm going to get started right on templates. So just come prepared for that. I have office hours in about 10 minutes. So come to that if you'd like. And that's it. Thank you for coming to the stream today. I hope you guys have a wonderful Monday. And I will see you guys tomorrow. Attacker asked when will assignment 6 be posted. Assignment 6 will go up during office hours. I'm going to try to get it up during office hours. I just want to review the PDF real quick to make sure that what I said makes sense. So assignment 6 will go up right away. And then code grade will also be up today for assignment 5. You are also very welcome. Cherry, you're welcome. Allie, you're welcome. Sarah, you are welcome. Chowder, you are welcome. Attacker, you are welcome. Synchro, you are welcome. Thank you all. I hope you have a great day. I will see you tomorrow.